Hi everybody, this is Walter Wesley. I'm your host for Short Attention Span Science Theater. Today's topic is going to be cancer and antioxidants, and very important subject. We've all heard about antioxidants. We've read antioxidants. It's a big marketing idea that you've heard a lot about. I'm going to explain a little bit how they work and with respect to cancer and how it grows. I'm going to start with basically a little rendition of a cell, or a little model of a cell, and show you what happens with cells. And if this was, say, a human cell, and one of many, you have something like 70 trillion cells in your body, and they do all sorts of different things: bone cells, skin cells, you name it, nerve cells. But they all have one thing in common: they have a lining. That's they call, the name for that is a phospholipid bilayer, and they also have a nucleus. And in that nucleus is where the DNA lurks. That's where the DNA is. I'll do a little, like say that was a DNA in there like that. These little ribbons, and then what happens in normal functioning of the body, you have the cell is basically attacked by free radical entities that want to get into that cell, or that get into that cell, and when they do, at a certain point when they do, they affect this DNA. And it's not the kind of exactly DNA that you pass on to your kids and everything. This is the DNA that's in charge of multiplying this cell. All your cells die and are replaced regularly throughout your life. It's said that every cell in your body is replaced every 7 years. Some are much quicker than that, but that happens by the process of this DNA divides up and creates another cell. So that's basically, in a nutshell, that's how we continue to live. Our cells are regenerated as we go along, and but what cancer is a mutation of that regenerative process. So if we look at a little closer about a DNA strand, all the information here. It's really long. It's super long if you in a microscopic type of situation. But if you were this DNA in this cell, and a free radical or an oxidizing entity, that means basically an entity would come in and basically damage the DNA at a certain point, and that would damage the growth factor would go on here, this thing being really long, but the growth part of your cell would still be growing, but its function would be messed up, and you would get a mutation, basically a cancer. So when this cell went to divide, it would be able to divide, it would be able to grow, and it would be able to live, but it wouldn't be right. It wouldn't do its proper job, and that's what cancer is. Cancer is a damaging of that growth DNA that doesn't work in its regular function, so you get all these cells multiplying in your body that aren't doing the right thing, and they're able to live. Cancer in a way is part of life as well. And that's how cancers grow. So what is it that's damaging these getting in there to damage those DNA molecules? Well, science tells us that these are something called free radicals. Free radicals. And free radicals causes damage and therefore are known to be responsible for cell death, but also for mutation. That's what. So the next episode on free radicals will be on free radicals and what exactly they are. So if you want to get a quick close-up shot of this, just to sort of show what this is about. Cancer, and this would be your cell. Free radicals are coming here, damaging this cell, and then getting in and damaging the DNA, and therefore causing cancer mutation.
Where do free radicals come from?
Free radicals are there. Free radicals are created or just in our environment. They can go around and they come around and they can be absorbed through our body through sunlight. Sunlight, the fluids we take in, the food we eat. They're positively charged entities. That means they are a type of entity that has like an atomic entity, and like it might look like this or something like this. But one thing about them is you've got to know about free radicals is that they are positively charged. Positively charged free radicals. Possibly they go into a cell because the cell has more negative charges in here than positive ones. So these positive charges are attracted into this area where they can cause damage, like cut it, make some damage in here, maybe lop it off. But this continues to grow. It just doesn't have the right stuff to be the right to make the right cell, so it's making the wrong cell. All right, that's it today for right now. My next little clip is going to be on free radicals and antioxidants. So stay tuned to my next short attention span science theater.